Hi, and welcome to the flipped instructional session for 2.01 Matter. As you begin a new unit, you want to be sure you're taking notes during the recording. Title your note page with the lesson number and title, so 2.01 Matter. As we get into the new unit, you do want to make sure that you download the note-taking guide. It is a Word document. Print it out and fill it out as you work through each lesson. There is an introduction to Matter, and this is an overview that goes over everything that you will be covering in this unit. So take a little bit of time to go through and look at that. And then as we get into the module introduction, it talks about matter being this substance all around you. It's anything that is made up of tiny particles called atoms. Your desk, your chair, and your computer are all made of atoms. The water in a water bottle is made from atoms, as is the bottle itself. Take a deep breath. The air you breathe in contains oxygen atoms. So you're surrounded by matter. As you get started, it is a great idea to fill out the vocabulary as you learned using in Unit 1, Part 2 test, you had to do the vocabulary matching, so you need those vocabulary words defined. So graphic organizers are just giving you skills on learning words, creating things, word families, things like that. They are not required. You do not have to turn those in, but the vocabulary document may be helpful if you want to print that out or put it in your notes. So this is just showing you a different way to learn tricky vocabulary words. It is not required and you do not have to submit it. So any graphic organizer isn't required. It's just showing you different skills to learn vocabulary words. And so as we start looking at matter, here's another page on a graphic organizer. It talks to you about how you can take notes if you want to do that a little bit of a different way. So there are many ways that matter can be described. How would you describe these things? A gold bar, a helium-filled balloon, an ice cube. So if we look at the answer, you could describe a gold bar as gold, shiny, hard, metallic, solid. Those are just a few examples. A helium-filled balloon, you could describe as latex or rubber, sphere-shaped object, less dense than air, meaning it floats. And an ice cube could be square-shaped, solid, cold, wet, any of those things. So matter can be described using these 6 properties: density, melting point, boiling point, chemical composition, chemical reactivity, and state at room temperature. So these 6 physical properties you need to put in your notes. Make sure you have that. You will look at this and use these properties throughout the unit. Molecules in motion. So do you know that your desk is moving right now? Even though it seems to be perfectly still, the molecules that make up your desk are moving. Molecules are constantly in motion. The motion of the molecules changes as matter changes from one state to another. Believe it or not, the solid phase molecules are still moving. While they're located in fixed positions, solid molecules vibrate back and forth. When a solid melts into a liquid, the molecules gain energy and move faster. And as the liquid molecules gain more energy, they move faster, converting the substance from a liquid to a gas. The gas molecules spread out, no longer tightly packed. So you can see as the temperature increases, the molecules move faster. So that's something important to know in your notes. So which type of phase possesses the least amount of energy? That would be the solid phase because the particles are closely packed, vibrating in place, thus they have the least amount of energy. To convert a substance from a gaseous to a liquid phase, what must happen to the energy? So energy is released or lost for the high energy gaseous molecules to convert to low energy liquid phase. So it's going to be cooling down, if we think of it that way, or going from high energy to low energy. So gas to a liquid is high energy to low energy. That may be noteworthy as well. So let's talk a little bit about physical versus chemical changes. Sometimes when a substance changes, you can still recognize it. This is because it is sometimes able to maintain its original identity even after the change. Take a piece of paper and tear it into pieces. You can still see that you have paper. This is a physical change. The identity of the paper has not changed. But if you set a piece of paper on fire, you won't be left with a pile of ashes. I'm sorry, you would be left with a pile of ashes, and you wouldn't be able to recognize the paper anymore. This is a chemical change. So look at the differences between chemical and physical changes. All right, so in a physical change, some of the physical properties of the substance may change. However, the identity of the substance does not. These physical properties include shape, size, temperature, color, and state of matter. So this might be something you want to include in your notes. For a chemical change, the chemical composition of the substance must change. That means it has become a new substance. Chemical bonds are broken, new bonds are formed, and that gives us a new substance. The identity of the substance changes as a result. So determine the type of change described below. Baking a cake, it's chemical because the identity of the cake batter has changed. Melting an ice cube is physical. We just changed the shape. We know that we still have water. Cutting bread is physical. The bread is not changed, still bread. And boiling an egg. Boiling an egg changes the proteins in the egg. Therefore, the identity of the egg changes. So most of the time, cooking is a chemical change. So up and atom. Who is Adam? Atom is not a person, but rather a thing, an extremely tiny thing. Atoms are particles that are the building blocks for all matter. The properties of atoms determine the properties of elements, ions, and molecules. In this module, you will learn more about the atom, its composition, and how atoms make up everything around you. Here is some matching that you can do, and these are vocabulary terms that you will need. So as you match those, if you take a screenshot, you can put those right into your notes. The periodic table includes a lot of information about atoms of each element. At first glance, the table seems oddly shaped and almost in a different language, with its numbers and letter symbols. Even the location of each element on the table is important. Horizontal rows on the periodic table called periods and vertical columns are called groups or families. Elements in the same group have similar properties. For example, find group 17 elements. They are all nonmetals and are very reactive. Squares on the periodic table. Each square of the periodic table includes important information. Notice the elemental symbols in each square on the table. These 1 to 2 letter symbols refer to the name of the element. Sometimes the symbols are not similar to the actual name. For example, lead has the symbol Pb, which refers to the Latin word plumbum, meaning liquid silver. So what does each element symbol represent? It's an abbreviation that represents a specific element. What element do you think the symbol C represents? The answer is carbon. And what element do you think the symbol S represents? The answer is sulfur. And you'll go more into the periodic table later in the unit. Numbers on the periodic table. So this is just an excerpt from the lesson that you'll see coming up. So I'm going to go ahead and move along into the rest of lesson 1. This is giving us an overview of the periodic table. It's talking about parts of the periodic table, so you're not missing out on anything there. And then we'll also be getting into talking about scientists and how they discovered the atom and how the composition of the atom changed. So it is important to note these when you go through and get to the lesson that talks about the scientist's name and what part of the atom he discovered. So for example, J.J. Thomson discovered the electron, and that added to what scientists before had already discovered. So he proposed a model of an atom in which a large positively charged sphere was balanced out by a number of electrons embedded throughout. A student of Thomson's, Ernest Rutherford, later disproved him, giving rise to the existence of the nucleus. Niels Bohr further changed the way atoms are reviewed. He hypothesized that electrons followed predictable paths similarly to the orbits of planets in the solar system. He based these orbits on energy levels and observed in various line spectra experiments. This model was so effective that it is still introduced as a starting point for understanding the atom to this day. The true model of the atom was developed by a series of scientists in the early 1920s and 30s with the development of quantum mechanics. Change, change, change. Everything changes. The materials around you are constantly changing because the materials on Earth consistently undergo chemical changes. During autumn, tree leaves change color and eventually fall to the ground dead. Animals consume food created by plants, which is then digested and broken down. Seeds use nutrients from the ground to grow and produce new fruit. In every aspect of the world, matter is always changing. So as we get to the end of the lesson, we're going to review a couple of things. Remember, we need to know what matter is, so you definitely want that definition. Any substance that takes up space and has mass, it is composed of atoms. How are physical and chemical changes different? So we know that physical changes are changes that do not result in changed identity of a substance, and chemical changes always result in the changed identity of a substance. How are the phases of solid, liquid, and gas different in terms of energy? So the atoms of matter in a solid phase possess the least amount of energy and vibrate about fixed positions. The atoms of matter in the gas phase possess the greatest amount of energy and spread out. So I always recommend for the lesson review slide, it's usually this one page, the points that they make and the answers they give, I would put those in your notes because those are the things that you should have gotten out of the lesson. So if you're filling in the note guide, make sure you have everything complete for 2.1 and that you include this information in your note guide as well. So as we wrap up, your next steps are to look for the Flip follow-up session for our Class Connect and attend Help Lab if you have any questions and need some extra help. Have a great day.